Good morning, all of you. Today we'll be starting with our next topic of Unit 1, that is flowchart. Before starting with the topic, let me tell you what we are going to study today. The objective of today's class is to give you an introduction to a flowchart. What are the different structures of a flowchart? For example, a sequence, decision, repetition, and case structures. We'll be explaining them. I'll be explaining them one by one. But before starting with the topic, I would like to show you a small video that will give you an idea about what a flowchart is and what we are going to do in today's class. I hope you have understood with the help of the video and you have got an idea what we are going to do today. So let's start now. What is a flowchart? We already know from the video that a flowchart is a diagram that basically depicts the flow of a program. It gives you the steps that we need to follow to get an output from the program. Now, when we talk about a flowchart, every flowchart has some symbols associated to it. What are those symbols? This first symbol, oval symbol, represents start and end of the program. So there are termination conditions. If I start a program, I need to write start in the oval. If I end a program, I need to write end in the oval. Then comes your arrow. An arrow is a line that is a connector basically that gives us the relationship between the different shapes that we have. So when I'm moving from one shape to another, or let's say when I'm moving from one step to another, I need to put an arrow in between that. Next comes your parallelogram. Now when we talk about a parallelogram, it's an input and an output. So while giving an input or while giving an output to the user, we need to use this parallelogram. Next is the rectangle. It's a process. A rectangle represents a process. And last one is your diamond, and a diamond indicates a decision. So wherever you see a diamond, that basically indicates a decision. Now let's start them one by one and let me explain you how it works with the help of an example. So we are taking an example over here. The figure shows here the flowchart of a pay calculating program. So we are taking an example of a pay calculating program. So let's start. We already know that termination conditions are start and stop, or we can say start and end. A start represents the starting point and end or stop represents the last point of a flowchart. Now, while calculating a pay program, and let's say we are calculating for an employee who is working on hourly basis in a company. So what do we need? There are two things that are required from the user. One is the number of hours that the user worked for, and also the number of the amount that a user is paid per hour. So these are the two things, and we need to multiply these two things and we get our output. Now, how do we create or how do we draw a flowchart using this? First we need to start. Then we display the user, or a system is asking the user to display how many hours the user has worked. User will input some number of hours. So you can see here we have used a parallelogram. Why? Because for input and output we need a parallelogram. Now you can see over here how many hours did you work, we need to write here. Then the user will enter the number of hours and we'll read those hours. Then display the message, how much do you get paid per hour? You read the pay rate, multiply both the number of hours with the pay rate and put it in a gross salary. So you can see over here, this is neither an input nor an output. It's a process. It's a process to calculate the gross pay. And once we have calculated the gross pay, we are displaying it with the help of a parallelogram. So we display the gross pay, and that it's the end of the program. So this is the figure that shows a flow chart that shows a pay calculating steps that are involved in a pay calculating program. So as we know, the terminals are start and end, right? The termination is end, the beginning is your start. Then all input output operations where we are taking either input from the user or we are giving an output to the user, we need to use parallelogram, right? And when we are calculating something that we have done by calculating the gross pay, that's the process, right? So this is a simple flow chart, and this is how we use a flow chart. Now, as we already have seen it in the objective, these are the different structures of a flow chart: a sequence, a decision, a repetition, and a case. Now let's pick them one by one and let me explain you how they work. So first let's start with a sequence. A sequence is basically a series of actions that are performed. Now when I say series of action, we have already done an example of it with the help of a pay calculating program. When there is no decision, there is no feedback, there is no loop, in that case it's a sequence of program. Simple, normal sequence, right? So you can see here start and end. We have a parallelogram and we have a process box over here. So we are using these two things to calculate a sequence. We have already done an example. Then comes your decision structure. Now this is an important one. Let's say if we have a condition anyway. Condition is like if it's 10 o'clock, then only I'll go to sleep. Then only I'll go to sleep. If it's 5 in the morning, then only I'll wake up. If it's 5, I'm early. If it's 6, I'm late. So what happens in this case is there's a condition involved. And with every condition, there is a different output. All conditions are not true. Out of all, only one condition is going to be true, as you can see over here. If x is less than y, then we need to calculate an a, and a will be x into 2. Or else, if x is not less than y, that means x will be greater than y, then a is equals to x plus y. So, what is the condition over here? X is less than y. We need to put a condition in a diamond box. A diamond box is the one which represents the decision, right? So it represents the decision. So let's see over here. X is less than y. For every decision, there can be 2 or more than 2 possibilities. Now, let's say we have 2 possibilities, yes or no, right? Normally, there are only 2 possibilities. So if it's yes and if it's no. If it's yes, we calculate a as x into 2 or else we calculate a as x plus y. Now can you see over here, these are your process boxes, rectangles. So this is a process we are calculating, but only one of them is true, not both of them. This is your if and else condition. Now let's say if we do not have an else condition, there can be a possibility where we don't have an else condition. So let's take an example of that. Let's say we are saying if x is less than y, we calculate a as x into 2. Then what will happen if x is more than y or equal to y? Nothing. Nothing will happen because we have no idea what is going to be happen. So we are not doing anything special if that happens. We'll just carry on with our program. Please remember, this is just a part of program that we are doing. We need to start, we need to read the numbers, we need to do all these things, then only we reach here. That's why this arrow shows here. So there is something above it, there may be something below it. We are only right now talking about your decision structure. So let's do an example of this. So if x is less than y, so there's only one action that is needed to be performed. If it's yes, we are calculating x times 2. But if it's no, we are not doing anything. This box will directly move to the, as you can see here, to the next statement. Whatever is the next statement. That means it goes outside the condition. Now condition is not only associated with decision, or condition is not only associated with this if else, it may be associated with loop also. What do you mean by that? Let's say I'm saying till x is less than y, calculate x plus 1. So what we are doing is, you can see here, it's a repetition structure. Now this is not a decision statement. So in if else was a decision control. In decision control also we were using a diamond box. But when it comes to a repetition structure, this is another kind of structure that we are talking about. So when it comes to a repetition structure, we still need to use a decision box. Why? Because whichever loop that we are using a condition associated to it. We enter a loop if the condition is met. Right? Let's say I have read two variables, x and y, and let's say the x value is 2 and y value is 5. Now, while x is less than y, so how do we show it in a flowchart? How do we show a repetitive structure in a flowchart? We need a decision because here we are taking a decision if x is whether while x is less than y. Now what we are doing here is, there's a condition over here. So there's a decision box over here. We are adding, if it's yes, we are adding 1 plus x. And because it is a repetition, we need to move back to the top of the decision structure. So it's a feedback kind of thing. That is why we call it a loop. Again, we check whether x is less than y or not. If x is still less than y, then we again add 1 to it. Then again goes back there. Right now, the condition that I have told you, in this case, I have inputted x as 2 and y as your 5. So every time I'm checking x less than y. Now x plus plus, so x will become now, after 2 it becomes 3, then it will become 4, then it will become 5. Now x is not less than y, so it will not enter the loop. Now we need to control the repetition. If we'll not control the repetition, let's say if I remove this display box, what will happen? I'm just writing x less than y and display x. I'm not adding any value to x. I'm not changing x. Now what will happen in this case? This becomes an infinite loop. This infinite loop will be of no use at all. Why? My program is stuck. It will never ever leave this decision box. X is less than y, display x. It will keep on displaying x till we kill the program. How can we modify it? I've shown you an example how it can be modified. We need to add 1 to x. That means we need to update the value of x so that at any point of time this condition will fail. And when this condition will fail, it will move to the next step. Fine. So this is how we can control a repetition structure, a way of controlling a repetition structure. Next comes the case structure. What do you mean by case? Let's say I would like to ask you some question which has some options associated to it. You will choose any one of them. A case structure also has a decision box. Why? You are taking the decision by picking up any one of the options out of all that are given. Right? So take an example over here. See an example over here. Let's say I am the employer of a company and I am giving bonus to the employees on the basis of the number of years of experience that they have. Let's say I'm saying that if employee has 1 year of experience, the bonus is of 100 rupees. If the employee has 2 years of experience, bonus is 200 rupees. If the employee has 3 years of experience, the bonus is 400 rupees. And if the employee has more than 3 years or any other apart from 1, 2, 3, we are paying that employee 800 rupees as a bonus. So there are 4 options that we have. That's a case structure. So what we are going to do in this case is, case years employed. Now, what are the options? 1, 2, 3 and other. So earlier in decision box, we were only using 2 options, yes or no. But in this case, our options are not yes and no. Our option is 1, 2, 3 or any other. Right? After that, we just give a process. Why? Because we are assigning bonus a value. So then we have a process box. And then all these processes will go to the next step. This is how we implement a case structure in a flowchart. Another important structure is a connector. Let's say I'm drawing a flowchart and my page finishes. I still need to draw a flowchart. So what I'll do is I'll put A at the end of the flowchart, and wherever the next step is, we'll put A at the top of it. Now what will this act as? This will act as a connector. So basically, if I put an arrow from this place to that place, as I have put right now, it's similar to that. This is what your connector is. Okay, the A connector indicates that the second flowchart segment begins where the first segment ends. This is what your connector is. Next comes modules. The position of the module symbol indicates the point the module is executed. A separate flowchart can be conducted for a module. You can see over here, this one. Can you see it's a rectangle with the two parallel lines in it. So this represents that we can create a separate flowchart for this, and separate flowchart may be available for this. It's a module. This represents one module. So start read input, call calculate pay function. It's a separate function that we have created. Display the result and end. This is how we represent a module. Now we need to combine structures while creating a flowchart. A flowchart will not be alone. We need to combine these structures. How do we do that? You can see over here. You can see over here. If x is greater than minimum, no or yes. Now there are two options. We are checking x between minimum and maximum. Minimum and maximum can be decided by us. Let's say I'm seeing whether x is between 10 and 20 or not. If it is below 10, I need to write outside limits. If it's above 20, I need to write outside limits. If it's between 10 to 20, we are fine with it. We need it that x is in limits. So we are checking over here, x is greater than minimum. No, then we display x is outside the limit. If yes, then we need to check whether x is less than maximum or not. So there is a decision box. After that, again a decision box. There is no process box, no input box, but a decision box after the decision box. This is combining of structures. So we have combined two decision structures over here. We again display, if it's no, we again displays outside the limit. If it's yes, we display that it is within the limit. That's it. This is what combining structure means. So let's have a summary of what a flowchart is and what are the different, symbols for a flowchart. Oval shaped for start and end, diamond for decision, parallelogram for input and output, circle is a connector, a rectangle is your process, and a double parallel lines in the rectangle represents your module, right? So these are the symbols that we have used in a flowchart. Now let's do some examples of a flowchart. This is a simple flowchart of a sequence, adding two numbers. We already know that we need to add start and stop at the end, right? So what do we need to do? First, we need two variables. So we declare a variable num1, num2, and we also declare a sum because we need to calculate or we need to store that sum in another variable. There are different ways of writing it. We read number 1 and number 2 because it's a read, then it is parallelogram. We write sum is equals to a plus b. We display the sum and we stop. This is a way to add two numbers. Now let's take another example of finding an item. Let's say I've lost some item and I need to find it. So it is not necessary that you are going to create a flowchart for a program. It can be for any real life problem also. And real life problems can be represented in the form of programs also. So we have a start and we have a stop. So in this case, we are writing stop looking as a stop. We look for a lost item. That's a process. Have you found it? If we have found it, yes, then we'll need to stop looking. But if we have not found it, do we need it? We need to see. If we need it, we need to again look for the item. And if we don't need it, stop looking. A simple example of finding an item using a flowchart. This is another example which is of alarm, waking up with the help of an alarm. A start and end, again are there, right? Now, alarm rings. Ready to get up? If it's yes, then you need to climb out of the bed. If no, you need to hit the snooze button. Now it's a snooze button, so again it will set for 5 more minutes. Again the alarm rings. So we have average of 3 times, right? This is an example, another example of creating a flowchart. So these are the references that we have used, or the books that you can refer for studying the topic. So let's summarize. We have talked about a flowchart and we have explained some examples of a flowchart. We already know we have many symbols that are there to represent a flowchart. The first symbol is the termination symbol, that is start and stop. Next symbol was a parallelogram, which is for input and output. Then we have a rectangle for process. Then we have a diamond for a decision. We have a rectangle with 2 parallel lines, which is for a module. A circle is for a connector. These are the basic symbols that we have for your flowchart. That's it for today. If you have any questions, you may contact on the email ID that is given on your screen. Thank you so much. That's it.